Coca-Cola's manufacturing process is a truly mind-blowing, high-speed operation. Every day, millions of bottles and cans of Coca-Cola are mixed, carbonated, and sealed with pinpoint accuracy to ensure the same legendary taste worldwide. In this documentary, we take you inside the high-tech factories, where advanced machinery and cutting-edge automation bring this iconic beverage to life. Get ready to witness the fascinating process behind the most consumed soda on the planet. The Coca-Cola process begins long before the beverage reaches the consumer, starting with the sourcing of raw ingredients and the preparation of the secret formula. The recipe is one of the most closely guarded trade secrets in the world, known only to a select few individuals. However, while the exact proportions of the ingredients remain undisclosed, the general components are well understood. Carbonated water, high fructose corn syrup or sugar, caramel color, phosphoric acid, natural flavors, and caffeine. The first step in manufacturing Coca-Cola is obtaining and preparing these ingredients. Water is the most important component, making up the majority of the drink. It must be purified to remove any impurities before being used in the production process. This is done through a series of filtration and purification steps, including sand filtration, carbon filtration, and reverse osmosis. These processes remove sediments, chlorine, organic compounds, and any potential contaminants, ensuring that only the purest water is used in Coca-Cola's production. The water purification process is vital because any variation in water quality could affect the final taste of the beverage. Once the water has been purified, it is ready to be mixed with the other ingredients. The syrup preparation process begins in a separate area of the factory, where high fructose corn syrup or sugar is combined with caramel coloring, phosphoric acid, and natural flavors. The caramel color gives Coca-Cola its distinct deep brown appearance, while phosphoric acid contributes to its tartness. The natural flavors used in Coca-Cola are a closely guarded secret, but they are essential in creating the beverage's unique taste. The caffeine is also added during this stage, ensuring that the drink maintains its signature stimulating effect. After the syrup is prepared, it must be carefully measured and mixed with the purified water. This is done through an automated batching system that ensures the precise ratio of syrup to water. The mixture is then subjected to a process called de-aeration, which removes any trapped air that could affect carbonation and shelf stability. This step is crucial because any excess air can lead to inconsistencies in taste and texture. Next, the mixture undergoes carbonation, one of the most important steps in the manufacturing process. Carbonation is achieved by injecting carbon dioxide into the liquid under controlled pressure and temperature conditions. The level of carbonation must be carefully calibrated to ensure that Coca-Cola has the right amount of fizziness. The CO2 used in this process is food grade and purified to remove any impurities. This step requires precision because too much or too little carbonation can alter the drink's mouthfeel and overall experience. Once the beverage has been carbonated, it is ready for bottling and packaging. However, before this can happen, the bottles or cans must be thoroughly cleaned and sterilized. This is a critical step in ensuring product safety and hygiene. Factories typically use high-pressure water jets and a sterilizing solution to clean the bottles before they are filled. Any residue or foreign particles in the bottles could compromise the quality of the drink, so this cleaning process is carefully monitored. With the bottles prepared, the filling process begins. The carbonated Coca-Cola mixture is dispensed into bottles or cans using high-speed filling machines that operate with incredible precision. The filling process must be conducted under controlled conditions to prevent foaming and loss of carbonation. The machines are designed to fill each container with the exact volume of liquid, ensuring consistency across all units. The filled bottles are then capped immediately to preserve carbonation and freshness. After capping, the bottles go through a labeling and coding process. Labels are applied to the bottles using automated machinery, and each bottle is imprinted with a date code to indicate its production date and best before date. This coding process helps with inventory management and quality control, allowing factories to track each batch of production. The labels are carefully inspected to ensure they are applied correctly, as any misaligned or missing labels can lead to packaging errors. Once labeled, the bottles move through a quality control checkpoint where they are inspected for any defects. This inspection process involves both human oversight and automated systems. High-speed cameras and sensors check for issues such as incorrect fill levels, damaged bottles, or improperly sealed caps. If any defects are detected, the affected bottles are removed from the production line to prevent them from reaching consumers. The quality control stage is one of the most critical aspects of Coca-Cola manufacturing, as it ensures that only products meeting the highest standards make it to market. After passing inspection, the bottles are packed into crates or cartons for distribution. The packaging process is fully automated, with robotic arms and conveyor belts handling the movement of products. The bottles are grouped into packs, shrink-wrapped for protection, and stacked onto pallets for transportation. The factory's logistics system ensures that the packaged products are efficiently stored and transported to distribution centers, where they are shipped to retailers, restaurants, and vending machines. The manufacturing process of Coca-Cola is designed for efficiency and precision at every stage. Factories are equipped with advanced technology and highly automated systems to ensure that production runs smoothly and consistently. Every step, from ingredient preparation to final packaging, is carefully monitored to maintain quality and safety standards. The final step before distribution involves conducting random sampling and additional quality control tests to ensure that the beverage meets Coca-Cola's strict standards. Samples are taken from each batch and tested in a laboratory for factors such as acidity, carbonation levels, and taste consistency. These tests help verify that the product remains true to Coca-Cola's signature flavor profile. If any deviations are found, adjustments are made to maintain quality. Coca-Cola factories operate around the clock, producing millions of bottles per day to meet global demand. The entire process is streamlined for maximum efficiency, ensuring that consumers receive fresh, high-quality beverages every time they purchase a bottle of Coca-Cola. The company places a strong emphasis on sustainability, incorporating water recycling and energy-efficient practices into its production processes. Water conservation efforts, CO2 recapture systems, and waste reduction initiatives help minimize the environmental impact of Coca-Cola manufacturing. Once the filled and capped bottles of Coca-Cola have undergone the initial stages of quality control, they move to an advanced inspection phase, where both automated systems and human supervisors ensure that every bottle meets the company's stringent standards. At this point, the bottles or cans are carefully checked for fill level accuracy, seal integrity, and carbonation retention. Sophisticated machines equipped with high-speed cameras analyze thousands of bottles per minute, identifying any anomalies such as underfilled or overfilled bottles, leaks, or incorrectly applied caps. If a defect is detected, the bottle is automatically removed from the production line and sent to a separate area for further evaluation. In cases where minor adjustments can be made, such as reapplying a cap that wasn't sealed properly, corrective measures are taken before the bottle is returned to the production process. However, if the defect compromises the quality of the beverage, the bottle is discarded to maintain consistency and uphold Coca-Cola's reputation for high-quality products. Parallel to this, another critical process occurs in the factory: batch testing. Randomly selected bottles from each production run are taken to an on-site laboratory, where they undergo extensive chemical and sensory analysis. Laboratory technicians assess factors such as pH levels, sugar concentration, carbonation levels, and overall taste profile to confirm that the beverage aligns perfectly with Coca-Cola's standardized formulation. Any deviation from the expected specifications results in a thorough investigation, ensuring that the issue is promptly identified and corrected. Once the bottles pass quality checks, they move on to secondary packaging. Coca-Cola is typically sold in various formats, including individual bottles, 6-packs, 12-packs, and even bulk cartons containing dozens of bottles or cans. High-speed automated packaging machines arrange the bottles into their designated configurations, wrapping them in plastic film or placing them into cardboard carriers. These machines operate with incredible precision, ensuring that every package is neatly assembled and securely sealed. At this stage, sustainability efforts come into play. Coca-Cola has invested heavily in reducing plastic waste and optimizing its packaging materials. Many of the plastic bottles used in Coca-Cola production are made from recycled PET, and the company continuously works toward increasing the percentage of recycled content in its packaging. In some regions, Coca-Cola also uses plant-based plastic materials to further minimize its environmental impact. The secondary packaging materials, such as cardboard cartons, are often sourced from recycled paper products, aligning with Coca-Cola's commitment to sustainability. Once packaged, the finished products are transported through a network of conveyor belts to a distribution staging area within the factory. Here, robotic palletizers stack the products onto pallets, organizing them efficiently for shipping. These robots use advanced algorithms to optimize space utilization, ensuring that the maximum number of products can be transported with minimal waste. The palletized products are then wrapped in protective plastic film to keep them secure during transit. The next step in the Coca-Cola manufacturing process is logistics and distribution. The company operates a vast global supply chain, with each factory producing beverages that are distributed to local and regional markets. Trucks, trains, and even cargo ships transport Coca-Cola products to distribution centers, warehouses, and retail locations around the world. The logistical network is meticulously planned to minimize transportation costs and reduce the carbon footprint of product distribution. Before shipping, warehouse personnel use barcode scanning systems and inventory management software to track every pallet of Coca-Cola. Each unit is assigned a unique barcode that corresponds to its production date, batch number, and destination. This tracking system enables the company to efficiently manage stock levels and quickly address any issues that may arise, such as recalls or shipment delays. In many cases, Coca-Cola products are delivered directly to retailers, including supermarkets, convenience stores, and vending machine operators. The company's extensive distribution network ensures that consumers can access fresh Coca-Cola virtually anywhere in the world. To maintain the freshness of the beverage, Coca-Cola implements a strict first-in, first-out inventory system, which prioritizes the sale of older stock before newer stock reaches store shelves. While Coca-Cola's distribution network ensures that the beverage reaches consumers efficiently, the manufacturing process doesn't end once the product leaves the factory. Coca-Cola factories also focus on sustainability initiatives aimed at reducing environmental impact. Water conservation is a major priority, given that water is the primary ingredient in Coca-Cola. Factories implement advanced water recycling systems, allowing them to treat and reuse water for non-product related processes such as equipment cleaning and cooling. Energy efficiency is another key focus. Many Coca-Cola plants utilize renewable energy sources such as solar and wind power to offset electricity consumption. The company also invests in energy-efficient machinery, reducing the overall carbon footprint of its manufacturing operations. Additionally, Coca-Cola works with local communities to support environmental sustainability initiatives such as reforestation programs and water replenishment projects. Another important aspect of Coca-Cola's manufacturing process is its adherence to strict food safety regulations. Factories comply with global food safety standards, including the Hazard Analysis and Critical Control Point System, which identifies and mitigates potential risks in food production. Employees undergo regular training on hygiene protocols, and strict sanitation measures are enforced throughout the facility. Production areas are regularly disinfected, and equipment is thoroughly cleaned after each batch to prevent cross-contamination. Coca-Cola also invests in research and development to continuously refine its production processes. Scientists and engineers work to optimize ingredient formulations, improve packaging materials, and enhance the efficiency of manufacturing operations. Innovation plays a crucial role in Coca-Cola's success, allowing the company to adapt to changing consumer preferences and market demands. For example, in response to growing health-conscious trends, Coca-Cola has introduced reduced sugar and zero sugar variants, all of which undergo the same rigorous manufacturing process as the original formula. One of the most impressive aspects of Coca-Cola's manufacturing process is its ability to maintain consistency across different regions. Regardless of where Coca-Cola is produced, whether in North America, Europe, Asia, or Africa, the taste and quality of the beverage remain the same. This consistency is achieved through strict adherence to Coca-Cola's global manufacturing standards, which dictate precise ingredient ratios, quality control measures, and production techniques. Each factory is regularly audited to ensure compliance with these standards, ensuring that consumers receive the same great-tasting Coca-Cola wherever they are in the world. Despite the high level of automation in Coca-Cola factories, human oversight remains essential. Factory workers play a crucial role in monitoring production lines, troubleshooting issues, and ensuring that operations run smoothly. From syrup blending technicians to quality control inspectors, every employee contributes to the success of the manufacturing process. Safety is also a top priority, with factories implementing comprehensive occupational health and safety programs to protect workers from potential hazards. The production of Coca-Cola is a complex and finely tuned process that extends beyond simply mixing ingredients and filling bottles. It involves numerous specialized stages that ensure the beverage maintains its signature taste, quality, and safety. As the bottled or canned Coca-Cola moves through the factory, the focus remains on maintaining efficiency, consistency, and sustainability. One of the key elements of Coca-Cola's production process is the careful management of carbonation. The carbon dioxide used to carbonate the beverage is sourced from food-grade suppliers and must meet strict purity standards. Maintaining consistent carbonation levels is critical because it affects the drink's texture, mouthfeel, and overall sensory experience. Carbonation is carefully controlled during the filling process to ensure that the right amount of CO2 is dissolved into the liquid. If the pressure or temperature is not properly maintained, the carbonation can dissipate too quickly, leading to a flat-tasting beverage. To prevent this, Coca-Cola factories use pressurized filling machines that ensure minimal CO2 loss as the beverage is transferred into bottles or cans. Once filled and capped, Coca-Cola bottles move through a final stage of quality assurance before they are packed and prepared for shipment. Each bottle is subjected to a high-speed laser inspection system that verifies the presence of the cap, ensures proper sealing, and checks for any defects in the glass or plastic. These laser inspection systems can detect even microscopic irregularities that might not be visible to the human eye, helping prevent faulty products from reaching the market. One of the most crucial aspects of Coca-Cola's manufacturing process is ensuring uniformity across all production facilities worldwide. To achieve this, the company employs a centralized quality control system that enforces strict guidelines for ingredient sourcing, syrup production, water purification, and carbonation. Each factory follows a standardized protocol, and periodic audits are conducted to verify compliance. This rigorous attention to detail ensures that a bottle of Coca-Cola produced in the United States tastes identical to one manufactured in Japan, South Africa, or Brazil. While consistency is a priority, Coca-Cola also tailors its formulation slightly to accommodate regional preferences and regulatory requirements. In some countries, the beverage is sweetened with high fructose corn syrup, while in others, cane sugar is used. Additionally, the amount of caffeine in the beverage may vary slightly depending on local guidelines. Despite these subtle differences, the core flavor profile remains the same, thanks to the precise blending of the secret formula. After passing through final quality control checks, Coca-Cola bottles and cans are directed toward packaging and palletizing. At this stage, packaging automation plays a key role in optimizing efficiency. Modern Coca-Cola factories use robotic arms and conveyor systems to sort, pack, and shrink wrap the products into multi-packs, cases, or crates. These machines work at incredible speeds, sometimes processing thousands of bottles per minute. Sustainability efforts are heavily integrated into the packaging process. Coca-Cola has made significant strides in reducing its environmental impact by using lightweight packaging materials, increasing the use of recycled plastics, and investing in refillable bottle programs. Many Coca-Cola factories have adopted a closed-loop recycling system in which used plastic bottles are collected, cleaned, and reprocessed into new bottles. This reduces reliance on virgin plastic and minimizes waste. Once the Coca-Cola products are packed and palletized, they are moved to the warehouse storage area within the factory. This area is carefully temperature controlled to preserve the beverage's freshness and carbonation levels. Coca-Cola's warehouse management system tracks each pallet's movement, ensuring that products are stored efficiently and dispatched in a timely manner. From the warehouse, Coca-Cola products are distributed through a highly organized logistics network. The company utilizes a combination of trucks, rail transport, and shipping containers to move its products from manufacturing facilities to regional distribution centers. These centers act as hubs that supply retailers, restaurants, and vending machines with fresh stock. Coca-Cola's logistics team uses advanced forecasting software to predict demand and optimize delivery routes, reducing fuel consumption and improving efficiency. Once Coca-Cola reaches retail locations, the company's work is not finished. Coca-Cola employs a global network of merchandising teams that ensure products are displayed prominently in stores, kept at the right temperature, and stocked in vending machines and coolers. These teams also monitor product rotation, ensuring that older stock is sold first to maintain freshness. Another key element in Coca-Cola's manufacturing and distribution process is its commitment to reducing water usage. Water stewardship is a major initiative for Coca-Cola, as the company relies heavily on water as its primary ingredient. Many Coca-Cola plants have implemented state-of-the-art water reclamation systems that allow them to recycle and reuse water in non-product applications such as equipment cooling and bottle washing. These efforts help minimize water waste and ensure responsible water management. In addition to water conservation, Coca-Cola has also invested in reducing its overall carbon footprint. Many of its manufacturing plants have adopted energy-efficient technologies, including solar panels, wind turbines, and advanced heat recovery systems. These measures help Coca-Cola decrease its reliance on fossil fuels and reduce greenhouse gas emissions. The company has also transitioned many of its delivery trucks to hybrid or electric models to further lower its environmental impact. While Coca-Cola's manufacturing process is highly automated, it still requires a skilled workforce to oversee operations. Factory employees play a crucial role in maintaining equipment, monitoring production lines, and conducting quality checks. They receive extensive training to ensure they understand food safety protocols, machinery operation, and emergency procedures. Coca-Cola places a strong emphasis on worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed machinery and industrial production environments. The level of precision required to produce Coca-Cola at such a massive scale is truly remarkable. Every ingredient, every machine, and every worker plays a vital role in ensuring that millions of bottles of Coca-Cola can be produced and distributed each day without compromising quality. The company's ability to manufacture its beverage with such consistency across different regions is a testament to the effectiveness of its standardized processes and advanced technology. Coca-Cola's manufacturing journey doesn't end once the product reaches consumers. The company continues to innovate, finding new ways to improve its production methods, reduce its environmental impact, and adapt to changing consumer preferences. Recent innovations include the development of plant-based plastic bottles, the introduction of lower-calorie and sugar-free alternatives, and improvements in energy-efficient bottling techniques. As Coca-Cola's manufacturing process continues beyond the bottling and packaging stages, the company remains focused on optimizing efficiency, reducing waste, and ensuring that every bottle that reaches the consumer meets its high standards. With millions of bottles and cans produced daily in factories around the world, Coca-Cola relies on a seamless integration of automated systems, rigorous quality control, and strategic logistics to maintain its position as one of the most recognizable beverages on the planet. One of the most important aspects of Coca-Cola's production process is its supply chain management. The company sources its ingredients from a global network of suppliers, ensuring that its factories receive high-quality raw materials consistently. The supply chain involves the coordinated movement of sugar or high fructose corn syrup, caffeine, caramel coloring, phosphoric acid, and natural flavorings, all of which must be stored under precise conditions to maintain their integrity. The syrup used to create Coca-Cola is produced in specialized facilities known as concentrate plants. These plants manufacture the highly concentrated base syrup, which is then shipped to bottling facilities worldwide, where it is mixed with purified water and carbonated before packaging. Once the concentrate reaches the bottling plant, it is diluted with purified water following Coca-Cola's standardized formulation. The water undergoes extensive treatment to remove any impurities, ensuring that the final beverage maintains the same taste, regardless of where it is produced. The carbonation process is carefully monitored, as even a slight variation in CO2 levels can affect the drink's mouthfeel and effervescence. Coca-Cola's research and development teams continuously refine the carbonation techniques to ensure the perfect balance of bubbles in every sip. With the beverage ready for packaging, Coca-Cola utilizes a diverse range of bottling formats to cater to different consumer preferences. The company produces its beverages in glass bottles, aluminum cans, and PET plastic bottles, each with its own specific manufacturing process. Glass bottles, for example, require a specialized filling line that ensures the bottles are sterilized before filling, capped securely, and transported safely. PET bottles undergo a process called blow molding, in which small preforms of plastic are heated and expanded into the shape of a full-sized bottle using high-pressure air. This method allows Coca-Cola to produce lightweight, durable bottles that are both cost-effective and recyclable. As the bottles and cans move through the high-speed production lines, they are continuously monitored by automated inspection systems. These systems use infrared sensors, X-ray technology, and high-speed cameras to detect any irregularities in fill levels, cap placement, and structural integrity. Bottles that do not meet Coca-Cola's quality standards are automatically removed from the line and discarded or recycled. This attention to detail ensures that only perfect products reach consumers. After being filled, capped, and labeled, Coca-Cola products are assembled into multi-packs or crates for easier handling and distribution. The packaging process is designed for maximum efficiency, with robotic arms swiftly arranging the bottles into their respective cases. Sustainability remains a key focus during this stage, with Coca-Cola implementing measures to reduce plastic waste by using lightweight packaging materials and increasing the use of recycled content. Many Coca-Cola plants have adopted a closed-loop recycling system, in which post-consumer PET bottles are collected, cleaned, and transformed into new bottles. This initiative significantly reduces the company's reliance on virgin plastics and helps minimize environmental impact. Once packaged, the products are transported to warehouse storage areas, where they are organized based on expiration dates and distribution routes. Coca-Cola follows a strict first in, first out inventory system to ensure that older stock is shipped out before newer stock, preventing waste and maintaining freshness. The company's advanced inventory management system tracks every case, ensuring that retailers receive the right products at the right time. From the warehouse, Coca-Cola products embark on their journey to retailers, supermarkets, vending machines, and restaurants. The company's logistics team meticulously plans transportation routes to optimize delivery efficiency and reduce fuel consumption. Coca-Cola operates a fleet of delivery trucks, many of which are equipped with refrigeration units to keep beverages cool during transit. In some regions, Coca-Cola has introduced electric delivery trucks to further minimize its carbon footprint. While Coca-Cola's production process is largely automated, human oversight remains essential at every stage. Factory employees play a critical role in ensuring that operations run smoothly, troubleshooting machinery issues, and maintaining stringent hygiene standards. Workers undergo regular training to stay up to date with food safety protocols, equipment operation, and emergency response procedures. The company prioritizes worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed production lines and industrial equipment. Coca-Cola's commitment to sustainability extends beyond its factories and supply chain. The company actively invests in water conservation projects, renewable energy initiatives, and recycling programs to reduce its overall environmental impact. In many regions, Coca-Cola collaborates with local communities to replenish water sources and support biodiversity conservation efforts. For every liter of water used in its production process, Coca-Cola works to return an equivalent amount to the environment through water stewardship initiatives. Another area of continuous improvement within Coca-Cola's manufacturing process is the development of innovative beverage formulations. In response to evolving consumer preferences, Coca-Cola has expanded its product portfolio to include sugar-free and low-calorie alternatives. The production of these variations follows a similar process to the original formula, with slight adjustments made to accommodate different sweeteners and flavor profiles. The introduction of Coca-Cola Zero Sugar and Diet Coke has required modifications to syrup formulation and taste testing procedures to ensure that these alternatives maintain the same crisp, refreshing experience as the classic version. Beyond traditional retail, Coca-Cola is also distributed through vending machines and fountain dispensers. The production of Coca-Cola syrup for fountain machines follows a slightly different process, as the syrup is shipped in concentrated form to restaurants and fast food chains, where it is mixed with carbonated water on site. This method allows for efficient storage and reduces packaging waste. The creation of Fanta inside a factory is a meticulous and finely tuned process involving chemistry, engineering, and strict quality control to ensure every bottle delivers the same bold, fruity flavor. Unlike some beverages that rely on a single uniform recipe, Fanta is produced in multiple flavors, each requiring its own balance of ingredients. This makes the production process both complex and fascinating, as every step must be carefully managed to maintain consistency and freshness across different variations. It all begins with the selection and preparation of ingredients. The core elements of Fanta include water, sweeteners, fruit flavorings, citric acid for tartness, preservatives to maintain shelf life, and carbon dioxide to give the drink its signature fizziness. However, each flavor, such as orange, grape, pineapple, or strawberry, requires a different combination of fruit extracts, natural or artificial colorings, and acidity regulators. These ingredients must meet strict quality and safety standards before they can be used in production. Water, being the main component of Fanta, is the first ingredient to be processed. The quality of the water used in soft drinks plays a crucial role in the final product's taste, clarity, and stability. Factories receive water from local sources, but before it can be used, it must go through an extensive purification process. This process begins with coarse filtration, where large particles, sediments, and debris are removed. The water is then passed through activated carbon filters to eliminate organic compounds, chlorine, and any undesirable odors or tastes. Finally, a reverse osmosis system is used to ensure the highest level of purity. This stage is critical because even the slightest variation in water quality can alter the flavor profile of Fanta. While the water undergoes purification, the syrup production process begins. This is where Fanta's distinctive flavor is created. In large mixing tanks, the essential ingredients are blended to form a concentrated syrup. Each flavor variation has its own unique formulation, requiring precise measurements of fruit extracts, sweeteners, and acids. Citric acid is commonly used to provide a tartness that enhances the fruity taste, while different natural and artificial flavorings are combined to create the signature taste of each Fanta variety. Sweeteners play an essential role in balancing the overall flavor. Depending on the region, the factory may use high fructose corn syrup, cane sugar, or alternative sweeteners such as aspartame for sugar-free versions. The exact ratio of sweetener to other ingredients must be meticulously controlled, as too much or too little can dramatically affect the drink's taste and mouthfeel. Once the syrup is mixed, it undergoes a process called homogenization. This ensures that all the ingredients are evenly dispersed and that no separation occurs during storage. The syrup is then transferred to large storage tanks, where it is kept under strictly controlled conditions before being combined with purified water. These tanks are equipped with continuous mixing systems to prevent any settling or inconsistencies in the formula. At this point, the production process moves to the batching stage, where the syrup is mixed with purified water in exact proportions. The goal here is to dilute the concentrated syrup to the precise flavor concentration required for Fanta. The ratio of syrup to water must be carefully maintained, as even a small deviation could result in a drink that is too strong or too weak in flavor. This blending process takes place in specially designed tanks, where the mixture is continuously stirred to ensure uniformity. While the flavor base is being prepared, another critical step is underway: deaeration. Deaeration is the process of removing excess oxygen from the liquid before carbonation takes place. If too much oxygen remains in the mixture, it can affect the beverage's stability, leading to unwanted changes in taste and shelf life. The deaeration process occurs under vacuum conditions, pulling out any dissolved air and preparing the liquid for the next crucial phase: carbonation. Carbonation is what gives Fanta its characteristic fizz. This step involves the careful infusion of carbon dioxide gas into the liquid under controlled pressure and temperature. The conditions must be just right, as the solubility of CO2 depends on temperature and pressure levels. If the carbonation process is not precise, the drink may become too flat or overly fizzy, both of which can negatively impact the consumer experience. The level of carbonation is carefully calibrated for each variety of Fanta, as some flavors require a different mouthfeel to enhance their particular fruit notes. Meanwhile, quality control tests are performed at every stage of production to ensure that the beverage meets strict consistency and safety standards. Samples from each batch are taken to an on-site laboratory where they are analyzed for acidity levels, sugar content, and overall taste. Highly trained technicians conduct these tests using specialized equipment to confirm that every batch meets the exact specifications required. If any deviation is detected, adjustments are made immediately before the product moves further along the production line. At this stage, the Fanta mixture is nearly complete, but it still has to be monitored for consistency before it can proceed to bottling. The temperature of the liquid must be kept within an optimal range to ensure the carbonation remains stable. If the temperature fluctuates too much, carbon dioxide may escape, resulting in a less fizzy drink. Advanced monitoring systems are used to track and adjust these conditions in real time, ensuring that the beverage is ready for the next stage of production. While the main beverage formulation is being perfected, the factory is simultaneously preparing the bottles and cans that will hold the finished product. Modern beverage production facilities use an advanced system for bottle manufacturing and preparation. For plastic bottles, the process begins with small PT preforms that are heated and expanded into their final shape using high-pressure air in a process called blow molding. This allows the factory to produce lightweight, durable bottles on-site, reducing the need for external suppliers and increasing efficiency. Glass bottles and aluminum cans follow a different preparation process. They are delivered to the factory pre-made and must undergo thorough cleaning and sterilization before being used. Each bottle or can is subjected to a high-pressure rinse with purified water and a sanitizing solution to remove any potential contaminants. Strict hygiene protocols ensure that every container is completely sterile before it reaches the filling stage. At this point in the production process, everything is coming together. The beverage is fully mixed, carbonated, and quality tested, while the bottles and cans are ready for filling. However, there are still multiple steps left to ensure that every bottle of Fanta meets the highest production standards. The next stage will involve high-speed filling, sealing, labeling, and additional quality control checks before the finished product is packaged and prepared for distribution. As the production line continues, the coordination of multiple systems working in perfect harmony becomes apparent. Every ingredient, machine, and quality control checkpoint plays a role in making sure that Fanta reaches consumers in the best possible condition. This highly organized process reflects the complexity behind what may seem like a simple bottle of fruity, fizzy refreshment. With the Fanta mixture fully prepared, carbonated, and quality tested, the production process moves toward the next major stage, the filling and bottling process. This part of manufacturing is one of the most crucial, as it requires absolute precision to ensure that every bottle or can is filled to the correct level, sealed properly, and protected from any external contamination. The entire operation is designed for efficiency, with high-speed machinery handling thousands of units per hour. Before the filling process can begin, the bottles and cans must be ready to receive the beverage. If plastic bottles are used, they have already gone through the blow molding process, where PET preforms are heated and expanded into their final shape. These bottles are lightweight, durable, and designed to withstand the pressure of carbonation. Glass bottles, on the other hand, arrive at the factory pre-made and must go through a thorough cleaning and sterilization process before being used. Similarly, aluminum cans are delivered in bulk and are also washed and sanitized to ensure absolute cleanliness. The sterilization process for bottles and cans is highly controlled. Each container is subjected to a series of high-pressure water jets and steam treatments, removing any potential contaminants that could affect the final product. In addition to physical cleaning, a chemical sanitization step is included, ensuring that no bacteria, dust, or residue remains inside the containers. Any bottle or can that fails to pass the cleanliness check is removed from the line and sent for reprocessing or disposal. Once the bottles and cans are verified as clean and sterile, they move along the production line toward the filling machines. These machines are designed to dispense the Fanta mixture with extreme precision, ensuring that each container receives exactly the right amount of liquid. The filling process must also take into account the carbonation level of the beverage. Since Fanta is a carbonated drink, the liquid is dispensed in a way that prevents excessive foaming and preserves the right amount of carbon dioxide. This is achieved through a pressurized filling system that maintains the carbonation inside the liquid as it is transferred into the bottles and cans. Different types of filling systems are used depending on the packaging format. For plastic bottles, a gravity filling system is often used, allowing the liquid to flow smoothly into the bottles while maintaining precise volume control. For aluminum cans, a counter-pressure filling system is more common, as it helps retain carbonation and prevent spillage. Regardless of the method, the goal is to ensure that each unit is filled with the same exact volume of Fanta while maintaining its fizziness and freshness. Once the bottles and cans are filled, they move to the capping and sealing station. This step must be completed almost instantly after filling to prevent any loss of carbonation. Plastic bottles are sealed with screw-on caps, which are applied using high-speed capping machines that tightly secure each cap onto the bottle's neck. These caps are designed to hold in the pressure from carbonation, ensuring that the drink remains fizzy until opened by the consumer. For glass bottles, a crimped metal cap, often called a crown cap, is used. These caps are pressed onto the bottle opening with a strong mechanical force, creating an airtight seal. The use of crown caps ensures that the carbonation remains intact, preventing any loss of fizz over time. Meanwhile, aluminum cans are sealed with pull-tab lids, which are crimped onto the can opening to create a pressurized seal. The precision required for this step is immense, as even the slightest sealing error can lead to leaks or loss of carbonation. With the bottles and cans now sealed, the next stage in the production process is labeling and batch coding. Labels are an essential part of Fanta's branding, providing consumers with product information, flavor identification, and branding visuals. The labeling process is highly automated, with machines applying labels to bottles at high speeds. These labels must be aligned perfectly, as any misalignment could make the product appear unprofessional or difficult to identify on store shelves. In addition to labels, each bottle and can receives a batch code, typically printed using a laser or inkjet printer. This code includes details such as the production date, expiration date, and batch number. The purpose of this coding is to allow for easy traceability in case of any quality issues. If a batch is found to have any defects, the factory can quickly identify and recall only the affected products, minimizing waste and ensuring consumer safety. Now that the filled and sealed Fanta bottles and cans have been labeled and coded, they move on to the final inspection phase. This is one of the most important parts of the entire manufacturing process, as it ensures that every single unit meets strict quality control standards. Advanced inspection systems are used to detect any defects in the bottles, cans, or caps. High-speed cameras and laser sensors scan each product to check for issues such as improper sealing, incorrect fill levels, label misalignment, or damaged packaging. Any defective products that do not meet quality standards are automatically removed from the production line. This ensures that only perfect, high-quality Fanta reaches consumers. The rejected bottles and cans are sent to a separate area for recycling or disposal, depending on the nature of the defect. If the issue is a minor one, such as a misaligned label, the product may be corrected and reintroduced to the production line. Once the final inspection is complete, the ready-to-ship bottles and cans are transported to the packaging area. This is where they are grouped into multi-packs or placed in cartons for easier distribution. The packaging process is fully automated, with robotic arms handling the placement of bottles into trays, shrink-wrapping multi-packs, and stacking cases onto pallets. The type of packaging used depends on the market. In some regions, Fanta is commonly sold in large multi-packs wrapped in plastic film, while in others, cardboard cartons are used to hold smaller packs together. Sustainability plays a significant role in Fanta's packaging process. Many of the plastic bottles used are made from recycled PET, which reduces plastic waste and environmental impact. Factories are continuously working to reduce plastic usage by making bottles lighter while maintaining their durability. Similarly, paper-based packaging materials are sourced from sustainable forests to ensure that the environmental footprint of production remains as low as possible. Once packaged, the finished products are transported to storage areas within the factory. These areas are climate controlled to maintain the freshness and quality of the beverages before they are shipped out to retailers. The inventory system used in the warehouse tracks every pallet of Fanta, ensuring that stock is rotated properly to maintain freshness. Products are organized based on their production dates, with older stock being distributed first to ensure that consumers always receive the freshest possible drinks. With Fanta now fully produced, filled, sealed, labeled, inspected, and packaged, the next stage of its journey involves logistics and distribution. Trucks, trains, and cargo containers are used to transport the beverages to supermarkets, vending machines, convenience stores, and restaurants. The logistics process must be carefully managed to ensure that Fanta reaches its destination in perfect condition without any loss of carbonation or freshness. The transition from the production line to distribution requires careful handling to ensure that every bottle and can maintains its quality from the factory to the consumer. Despite the high levels of automation in the manufacturing process, this stage still requires a combination of technology, planning, and human oversight to maintain efficiency. As soon as Fanta bottles and cans are packaged, they are transported via conveyor belts to a dedicated storage area within the factory. These warehouse zones are carefully climate controlled to prevent any degradation in quality. Since Fanta is a carbonated beverage, it must be kept at optimal temperatures to ensure that the carbonation remains stable and does not dissipate before consumption. Any exposure to excessive heat or fluctuating temperatures could lead to pressure changes inside the bottles and cans, potentially affecting the taste and texture of the drink. Warehouses use an advanced inventory tracking system to monitor the movement of every batch of Fanta that is produced. Barcodes or QR codes on the packaging allow for real-time scanning and tracking, ensuring that each unit is logged into the system. This technology helps maintain an efficient first-in, first-out system, where older stock is shipped out first to ensure freshness. The software also helps manage supply and demand, ensuring that production aligns with market needs and avoiding unnecessary overproduction. During this stage, quality control does not stop. Factory personnel conduct regular spot checks, examining random samples from different batches to ensure that the carbonation levels, flavor, and overall integrity of the product remain consistent. Producing instant coffee in a factory is a complex process that combines food science, advanced engineering, and cutting-edge machinery to transform coffee beans into a soluble, ready-to-use product. From sourcing and roasting coffee beans to freeze-drying or spray-drying the brewed extract, each step in the production process is meticulously planned to ensure consistency, flavor preservation, and efficiency on a massive industrial scale. Let's take an in-depth look at the step-by-step factory process that goes into making instant coffee. The journey begins with sourcing green coffee beans. Factories procure these beans in large quantities from coffee-growing regions such as Brazil, Colombia, Vietnam, and Ethiopia. Since instant coffee requires consistent flavor profiles, manufacturers often blend beans from various regions to create a balanced and standardized flavor. Upon arrival at the factory, the green coffee beans are subjected to rigorous quality control checks. Samples are tested for size, moisture content, and defects to ensure the beans meet the factory's standards for processing. Once approved, the beans are stored in massive silos made of food-grade stainless steel or aluminum to protect them from contamination, pests, and humidity. These silos are equipped with automated systems that precisely dispense beans onto the production line. The first major step in processing the beans is cleaning. Coffee beans, even after being cleaned at their origin, may still contain impurities such as dirt, stones, sticks, or metal fragments. In the factory, the cleaning process involves several stages. Vibrating screens sift the beans to remove large debris, while air classifiers blow away lighter materials like husks or dust. Magnets are used to extract any metallic particles. Some factories also employ optical sorting machines, which use cameras and sensors to identify and remove defective beans or foreign objects. This thorough cleaning ensures that only high-quality beans proceed to the roasting stage. Roasting is a critical step in developing the rich, complex flavors of coffee. Factories use industrial coffee roasters, which can process thousands of pounds of beans per hour. The roasting process is controlled by highly advanced systems that allow operators to customize the roast profile for specific flavor outcomes. For instant coffee, medium to dark roasts are commonly used, as they bring out bold flavors that translate well into the final soluble product. Roasting temperatures typically range between 370 and 540 degrees Fahrenheit, depending on the desired flavor profile. During roasting, the beans undergo the Maillard reaction, a chemical process that creates the characteristic aromas and flavors of coffee. The roasting equipment includes temperature sensors and real-time monitoring systems to ensure uniform roasting across large batches. Once the roasting is complete, the beans are cooled rapidly to stop the roasting process and prevent overcooking. Factories use air cooling systems or water spray cooling, depending on the setup. Cooling is an important step, as improperly cooled beans can lose their flavor or become brittle. After cooling, the beans are sent to grinding machines. The grinding stage reduces the roasted coffee beans into smaller particles, which will be used for the brewing process. Factories use industrial grinders, such as roller mills or hammer mills, capable of producing a consistent grind size. The grind size is crucial because it affects the extraction process that follows. For instant coffee, a relatively coarse grind is typically used to optimize the brewing process in the factory. The ground coffee is then stored in intermediate holding bins, where it is kept fresh until it is ready to be brewed. Brewing is the next major step in instant coffee production, and it is carried out on an industrial scale. Massive brewing systems, similar to oversized percolators, are used to extract the soluble compounds from the ground coffee. These systems consist of large stainless steel extraction tanks or columns, which are designed to hold thousands of gallons of water and coffee grounds. Hot water is circulated through the coffee grounds at precise temperatures and pressures, mimicking the brewing process used at home, but on a much larger scale. Typically, water temperatures range between 190 and 205 degrees Fahrenheit, and the brewing time is carefully controlled to maximize flavor extraction while minimizing bitterness. The brewed coffee concentrate, a liquid containing the extracted soluble compounds, is then filtered to remove the spent coffee grounds. Factories use advanced filtration systems, such as centrifugal separators or fine mesh filters, to ensure that no solid particles remain in the liquid. The spent grounds are often dried and repurposed as fertilizer or biomass fuel, making use of every part of the raw material. At this stage, the coffee concentrate is a highly aromatic liquid, but it is still far from the final product. The challenge is to transform this liquid concentrate into a stable, dry, and soluble form. Factories use one of two main methods for this: spray drying or freeze drying. Spray drying is a fast and cost-effective method that is commonly used to produce instant coffee powder. The coffee concentrate is first preheated to reduce its moisture content. It is then pumped into a tall, spray drying chamber equipped with nozzles that disperse the liquid into fine droplets. At the same time, hot air, typically around 480 degrees Fahrenheit, is blown into the chamber. As the droplets fall through the chamber, the water in the coffee concentrate rapidly evaporates, leaving behind fine coffee powder. Spray drying is efficient and capable of processing large volumes, but the high temperatures can sometimes lead to a slight loss of flavor and aroma. Freeze drying, on the other hand, is a more delicate and sophisticated process that better preserves the natural flavors and aromas of coffee. The coffee concentrate is first frozen at extremely low temperatures, usually around 40 degrees Fahrenheit, to form solid slabs or granules. These frozen coffee pieces are then placed in a vacuum chamber. Inside the chamber, the frozen water in the coffee undergoes sublimation, a process where ice turns directly into vapor without passing through the liquid phase. This method requires precise control of temperature and pressure and takes longer than spray drying, but it produces high-quality granules of instant coffee that dissolve easily in water. After the drying process, the instant coffee is sifted and graded by particle size to ensure uniformity. Any oversized or undersized particles are removed, and the coffee is blended to create a consistent final product. Factories conduct rigorous quality control tests at this stage, including flavor analysis, solubility testing, and moisture content measurement. These tests ensure that the instant coffee meets the desired standards for flavor, aroma, and texture. Packaging is the final step in the production process, and it is designed to protect the coffee from moisture and preserve its freshness. The dried instant coffee is transported to high-speed filling machines, which dispense precise amounts of coffee into jars, tins, or pouches. Factories use nitrogen flushing systems to replace oxygen in the packaging, as oxygen can degrade the coffee over time. The jars are sealed with airtight lids, while pouches are heat-sealed to maintain freshness. After sealing, the packages move to labeling stations, where automated systems apply branding, ingredient lists, and expiration dates. Each package undergoes a final inspection using vision systems to ensure there are no defects in the seals or labels. Once approved, the packages are packed into cartons or cases using robotic packing systems and prepared for shipping. Pallets of instant coffee are stacked and wrapped for stability before being loaded onto trucks or containers for global distribution. Throughout the entire process, factories rely on advanced automation and engineering to ensure efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems monitor and control every stage of production, from roasting and brewing to drying and packaging. Real-time data on temperature, pressure, humidity, and other parameters allows operators to make precise adjustments as needed, minimizing waste and ensuring high-quality output. Hygiene and food safety are also paramount in instant coffee production. Production areas are designed with food-grade stainless steel surfaces, seamless flooring, and clean room environments to prevent contamination. Positive air pressure systems are used to keep airborne particles out of critical areas, and employees are required to follow strict hygiene protocols. including wearing protective clothing and adhering to cleaning schedules. Factories are regularly inspected and certified to meet international food safety standards. Inside a tea factory, the transformation of fresh tea leaves into the familiar tea bags, loose leaf tea, or powdered varieties is a carefully orchestrated process. It is a seamless blend of tradition, precision engineering, and science. Every step of the way, from leaf intake to packaging, is designed to preserve the flavor, aroma, and quality that tea enthusiasts have come to expect. While the type of tea being produced, whether black, green, oolong, or white, dictates specific steps in the process, the overall journey is one of meticulous attention to detail, where both manual expertise and advanced machinery play vital roles. The process begins at the tea gardens, where leaves from the Camellia sinensis plant are plucked at peak quality. For most teas, workers handpick only the top 2 leaves and a bud from each branch, as these tender parts of the plant produce the best flavor and aroma. After harvesting, the leaves are transported to the factory as quickly as possible to prevent spoilage or fermentation during transit. Many tea factories are strategically located near plantations to minimize delays and ensure freshness. Upon arrival at the factory, the tea leaves are weighed and inspected for quality. Modern tea factories are equipped with automated intake systems that separate leaves from debris such as twigs or foreign matter. Vibrating conveyor belts or mechanical sieves are commonly used at this stage to remove unwanted materials. For higher grade teas, additional manual inspections may be carried out to ensure only the finest leaves proceed to the next step. The fresh leaves are then carefully spread out in thin layers on large trays or conveyor belts, marking the beginning of the first stage in tea processing. Withering. Withering is a critical step in tea production, as it reduces the moisture content of the fresh tea leaves and prepares them for the subsequent stages of processing. In the factory, withering is typically carried out in withering troughs, long, shallow trays equipped with a system of fans and controlled airflow. Fresh tea leaves are laid out on these trays, and air is circulated over them for several hours to slowly remove moisture. For black tea, withering may last anywhere from 12 to 18 hours, while green tea requires a shorter withering time, as it needs to retain more of its fresh, grassy flavor. Temperature and humidity are carefully controlled using automated climate systems to ensure consistent results. During this stage, the leaves become softer and more pliable, making them ready for rolling. The next stage is rolling, where the tea leaves are twisted and shaped to release their essential oils and initiate oxidation if required, as with black and oolong teas. Factories use large mechanical rolling machines equipped with heavy, grooved plates or rollers. These machines apply pressure to the leaves, breaking down their cell walls and releasing their natural juices. The released juices react with oxygen in the air, beginning the oxidation process that gives black tea its characteristic flavor and color. Rolling machines can be adjusted to produce different shapes and textures, depending on the type of tea being made. For example, green teas may be rolled into tight pellets for varieties like gunpowder tea, while black teas are often left in long, wiry shapes. At this point, the production process diverges depending on the type of tea being manufactured. For black tea, oxidation is the next key step. Oxidation, often mistakenly referred to as fermentation, is a chemical process that darkens the tea leaves and develops the rich, robust flavors associated with black tea. In factories, oxidation typically takes place in large, temperature-controlled rooms, where rolled tea leaves are spread out on trays or conveyor belts. These rooms maintain a controlled environment with high humidity and a temperature of around 77 to 86 degrees Fahrenheit. The leaves are periodically monitored to ensure they achieve the desired level of oxidation, which can take anywhere from 30 minutes to several hours, depending on the tea. As the leaves oxidize, they turn from green to a reddish-brown color, releasing the aromatic compounds that define black tea. In contrast, for green tea production, oxidation is intentionally prevented. To preserve the vibrant green color and fresh vegetal flavor of the leaves, factories employ a process called fixation, also known as kill green. This step involves heating the leaves immediately after rolling to deactivate the enzymes that cause oxidation. Factories use either steam or dry heat for this purpose. For Japanese-style green teas, like sencha, the leaves are steamed in specialized machines, while Chinese-style green teas are often pan-fried in large heated woks or rotating drum roasters. Fixation requires precise temperature control, as overheating can burn the leaves and underheating can fail to stop oxidation completely. Once oxidation or fixation is complete, the next step is drying, which reduces the moisture content of the tea to make it shelf stable. Drying is typically carried out in large industrial dryers or ovens equipped with temperature controls and airflow systems. Conveyor belt dryers, in which the leaves are gradually moved through a heated chamber, are common in large-scale tea factories. The temperature during drying ranges from 194 to 248 degrees Fahrenheit, depending on the type of tea and the desired final moisture content, which is usually around 3 to 5%. This step is crucial for locking in the flavor and aroma of the tea while ensuring it will not spoil during storage. After drying, the tea leaves are sorted and graded. In the sorting process, leaves are separated by size, shape, and quality using a combination of vibrating sieves, air separators, and optical sorting machines. Whole leaves, broken leaves, and small particles are separated into different grades, which are used for various tea products. For instance, whole leaves are often reserved for premium loose-leaf teas, while smaller particles are used for tea bags. Some factories also employ advanced laser sorting machines that can detect and remove any remaining foreign objects or off-spec leaves. Blending is another key step in tea production, especially for brands that aim to create consistent flavor profiles. Many teas are blended by mixing leaves from different regions, harvests, or even types of tea. Blending is carried out in large rotating drums or mixing machines, where precise quantities of different teas are combined to achieve the desired flavor. For flavored teas, additional ingredients such as dried fruit pieces, herbs, or essential oils are added during this stage. For example, Earl Grey tea is made by blending black tea leaves with bergamot oil, while chai blends often include spices like cinnamon, cardamom, and cloves. Once the tea has been blended and sorted, it is ready for packaging. Packaging is a highly automated process in modern tea factories. For loose-leaf tea, the leaves are weighed and sealed in airtight bags, tins, or foil-lined pouches to preserve freshness. For tea bags, the leaves are measured and packed into filter paper, which is then cut and sealed into individual tea bags using high-speed machines. Many factories also produce pyramid-shaped tea bags, which allow for larger leaves and better infusion. After filling, the tea bags are placed into cartons or boxes, which are sealed and labeled with branding, lot numbers, and expiration dates. Throughout the entire process, quality control plays a vital role in ensuring the tea meets rigorous standards. Factories employ trained tea tasters who sample the tea at various stages of production to assess its flavor, aroma, and appearance. Advanced laboratory equipment is also used to measure moisture content, microbial activity, and other parameters that affect the quality and safety of the final product. Additionally, factories must comply with food safety regulations and certifications, such as ISO 22000 or HACCP, to ensure their tea is safe for consumption. Cocoa powder, the cornerstone of countless recipes from rich chocolate cakes to creamy hot cocoa, is the product of a complex and fascinating manufacturing process that combines agricultural expertise with advanced industrial engineering. Behind every tin or packet of cocoa powder lies a detailed, multi-step operation where raw cacao beans are transformed into the fine, flavorful powder that has become a staple ingredient in kitchens around the world. This process begins on cacao farms and culminates in a factory where specialized equipment and precise techniques ensure the consistency, flavor, and quality of the finished product. Let's take an in-depth journey into how cocoa powder is made, exploring each stage of the process, from bean to powder. The story of cocoa powder begins with the cacao tree, which thrives in tropical regions near the equator, such as West Africa, Southeast Asia, and Central and South America. The cacao tree produces pods that contain cacao beans surrounded by a sweet, sticky pulp. These beans are the raw material for cocoa powder. Once harvested, the pods are split open to extract the beans, which are then immediately subjected to the first critical step in the process: fermentation. Fermentation is a natural and essential process that develops the flavor precursors in cacao beans. After being removed from the pods, the beans and their surrounding pulp are placed into shallow wooden boxes or large banana leaf-lined baskets, where they ferment over a period of 5 to 7 days. During this time, natural yeasts and bacteria break down the sugars in the pulp, generating heat and causing the temperature in the fermentation pile to rise significantly, often reaching over 120 degrees Fahrenheit. This heat triggers a series of chemical reactions within the beans, developing their characteristic chocolate flavor while reducing bitterness. The beans are turned periodically to ensure even fermentation and prevent spoilage. Once fermentation is complete, the beans are removed from the boxes or baskets and sent to the next stage: drying. Drying is critical for stabilizing the fermented beans and reducing their moisture content to a level suitable for storage and transport. Traditionally, cacao beans are dried under the sun, spread out in thin layers on large drying racks or patios, and turned regularly with wooden rakes to ensure even drying. In modern cocoa production, factories may use mechanical dryers when weather conditions are unsuitable for sun drying or to speed up the process. These machines blow heated air over the beans to achieve the target moisture content, which is usually around 6 to 7%. Proper drying is essential because any excess moisture could lead to mold growth during storage or shipping. Once dried, the beans are sorted, graded, and packed into jute bags or bulk containers, ready for shipment to processing facilities. Upon arriving at the cocoa processing factory, the dried cacao beans are carefully inspected for quality. Factories use advanced optical sorting machines equipped with cameras and lasers to identify and remove defective beans, such as those that are cracked, moldy, or undersized. Any remaining debris, like stones or twigs, is removed using vibrating screens and air separators. Once the beans are cleaned, they are stored in large silos made of food-grade stainless steel, which protects them from contamination while allowing for easy access as the beans move through the production line. The first step inside the factory is roasting, a critical stage that brings out the rich chocolatey aroma and flavor of the beans. Industrial roasters are designed to handle large volumes of cacao beans, roasting them at precise temperatures that can range from 250 to 300 degrees Fahrenheit. The exact temperature and duration of roasting depend on the type of cocoa powder being produced, as darker roasts develop more intense flavors, while lighter roasts preserve subtle fruity or floral notes. During roasting, the shells of the beans become brittle, and the internal nibs, which contain the cocoa solids and cocoa butter, begin to separate from the shell. Sensors and computer-controlled systems monitor the roasting process to ensure consistency across batches. Once roasting is complete, the beans are rapidly cooled, using air or water to prevent overcooking. The next stage is winnowing, where the roasted beans are cracked open to separate the nibs from the outer shells. This process is carried out using winnowing machines, which use a combination of mechanical rollers and air currents to break the shells and blow them away. The result is a pile of clean, roasted nibs, which are the purest form of cacao and the raw material for all cocoa products. The nibs are then ground into a thick, viscous liquid known as cocoa liquor, despite containing no alcohol. The grinding process involves heavy-duty industrial grinders, such as roller mills or stone grinders, which crush the nibs into tiny particles. This process releases the natural cocoa butter within the nibs, creating a smooth liquid that flows easily. The particle size is reduced to less than 30 microns during this stage to ensure a silky texture. Cocoa liquor is the base ingredient for many chocolate products, but for cocoa powder production, the focus shifts to separating the two main components of the liquor, cocoa solids and cocoa butter. The separation of cocoa solids and cocoa butter is achieved through pressing. Cocoa liquor is fed into hydraulic or screw presses, which apply immense pressure, up to 6,000 pounds per square inch, to squeeze out the cocoa butter. This process leaves behind a solid cake of compressed cocoa solids. The extracted cocoa butter is collected and filtered for use in other products, such as chocolate bars, cosmetics, or pharmaceuticals. Meanwhile, the cocoa cake, which still contains a small amount of residual fat, becomes the foundation for cocoa powder. The cocoa cake is cooled and broken into smaller chunks before being fed into pulverizing machines, where it is ground into a fine powder. Factories use various types of grinding equipment, such as pin mills or ball mills, to achieve the desired particle size for cocoa powder. This step is critical for ensuring that the final product has a consistent texture and dissolves easily in liquids. The fineness of cocoa powder can vary depending on its intended use. For example, baking-grade cocoa powder is typically ground finer than drinking cocoa. At this point, the cocoa powder is almost ready, but one additional process may take place depending on the type of cocoa being produced: alkalization, also known as Dutch processing. Alkalization involves treating the cocoa powder with an alkaline solution, such as potassium carbonate. This process neutralizes the natural acidity of the cocoa, darkens its color, and gives it a smoother, milder flavor. Alkalized cocoa powder is often used in baking and beverages, as its reduced acidity reacts differently with leavening agents like baking soda. Once the cocoa powder is fully processed, it undergoes rigorous quality control tests to ensure it meets the manufacturer's standards. Samples are tested for flavor, color, pH levels, fat content, and particle size. Factories use advanced laboratory equipment, such as spectrophotometers and viscometers, to measure these properties with precision. Any deviations from the desired specifications are identified and corrected before the product moves to the packaging stage. Packaging is the final step in the production process, and it plays a critical role in preserving the freshness and quality of the cocoa powder. The powder is first sifted to remove any clumps or oversized particles, ensuring a uniform texture. It is then transferred to automated filling machines, which dispense precise amounts of cocoa powder into containers, such as tins, pouches, or bulk bags. For retail packaging, the containers are often flushed with nitrogen gas before sealing to remove oxygen and prevent spoilage. Labels are applied to the packages, including information such as the brand, product type, lot number, and expiration date. Once packaged, the cocoa powder undergoes a final round of inspections, where advanced vision systems check for defects such as improper sealing, misaligned labels, or damaged containers. The finished products are then packed into cartons or cases using robotic packaging systems. Palletizing robots stack the cartons neatly onto pallets, which are shrink-wrapped for stability and loaded onto trucks or shipping containers for distribution. Today's journey towards KFC tenders begins in the serene environment of this amazing poultry house, which is located in the United States. Being KFC's biggest supplier, these farms are not just places where chickens are raised. They are carefully designed spaces dedicated to the well-being of the birds. Automatic dispensers play a key role in maintaining the chicken's health. Fresh, clean water is always available thanks to these dispensers. In spacious barns, chickens are given room to roam freely, unlike the cramped conditions found in some other farming setups. This freedom is crucial because a stress-free environment helps the chickens grow healthy and robust. Once the chickens are deemed chicken collection ready, these modern collecting machines arrive at the farms. These machines are somewhat like large vacuum systems, but with a gentle touch. Instead of sucking up the chickens roughly, they handle them with great care. Once the chickens are collected, they are placed into clean, secure crates. These crates are specifically designed to ensure the safety and calm. This helps reduce stress and keeps them calm throughout the trip. Upon arrival at the processing plant, the chickens are unloaded with the same care and attention they receive throughout their journey. The unloading process is handled by experienced workers who use a bunch of conveyor belts and understand the importance of gentle handling. The focus remains on maintaining their health and safety, which is crucial for producing high-quality products. The processing plant is a marvel of modern technology, designed to handle large volumes of chickens while ensuring efficiency and precision. As the chickens travel along the conveyor belt, they pass through a stunning machine. This machine is designed to render the chickens unconscious in a way that is both quick and painless. One of the most important steps in the processing plant is ensuring the chickens are treated humanely. This commitment to humane treatment reflects the industry's focus on animal welfare. The chickens move to the feather removal stage. This is where a specialized machine removes all the feathers from the chickens. One of the first steps involves separating the chicken feet from the rest of the body. After the feet are removed, the chickens move on to the next stage, where their internal sections are cleaned out. Once the internal cleaning is complete, the chickens are thoroughly washed. The washing process is held in a pool of water that also uses high-pressure water jets to remove any remaining blood or impurities. With the chickens dried, the next stage involves cutting them into various parts, keeping the breast pieces for KFC tenders processing, as they are known for their juicy tenderness. The rest of the chicken will also be cut into pieces and collected for further selling purposes. I almost forgot, but the machines, before making cuts to the breast pieces, use abrasive roller pins to conveniently remove the skin from the breast piece, so you never have to compromise on taste and quality. Specialized machines are used to make precise cuts, separating the breast from the rest of the chicken. These machines are designed to handle the chicken gently while ensuring that each cut is clean and accurate. The breast pieces are cut from the bony parts of the chicken, which are handled separately. Once the chicken breasts are separated from the rest of the chicken, they are carefully collected. Now, the breast pieces are being placed into drum rollers. This part of the process is designed to make the chicken breasts even juicier. The drum rollers gently tumble the chicken pieces, allowing them to lock in moisture and enhance the overall tenderness of the chicken. After the drum rollers, the chicken pieces move to the sorting stage. Here, they are manually placed on running belts, more like sieves. These sieves allow experts to inspect each piece carefully to ensure that the chicken is safe to eat. The pieces are then sprayed with a solution responsible for removing any harmful bacteria from the surface. The spray helps to reduce the risk of contamination and ensures that the chicken is clean and ready. We are really working hard to entertain you guys. If you think we deserve your like, please hit that like button. Once the chicken pieces are thoroughly cleaned, they are coated with flour to create a delicious texture for the chicken and help in forming a crispy coating when fried. Importantly, no artificial ingredients are used in this flour coating. The flour-covered pieces are then transported on shaker or vibrating belts, which ensure that the coating is applied evenly and that the pieces are aligned in a uniform shape. This partial frying locks in the tenderness and juiciness of the chicken while giving it a golden brown color and a crisp texture on the outside. Cheese cubes are a popular snack and ingredient in many dishes, prized for their gooey, melty centers and crispy coatings when fried. The battered cheese cubes are passed through a bed of breadcrumbs in the automatic machine. These machines not only increase efficiency, but also ensure consistency and quality in the final product. By automating the process, manufacturers can produce large quantities of cheese cubes with perfect coatings every time. From mixing ingredients to packaging the final product, every step is designed to create patties that are not only delicious, but also made with remarkable efficiency. Carrying the capacity of 1,500 liters at a time, they can literally cope with the bigger projects, like more than hundreds of thousands of patties every day. Check out that smooth process to package the burger patties to avoid inconvenience. Enjoying that burger crunch or dreaming right now. Anyways, in both cases, you need to complete that fast food party with chicken nuggets. Even if you don't like those crispy and juicy chicken nuggets, you've got to watch this video that may trigger some taste buds in you. For that appealing golden brown appearance, they fry these nuggets for around 70%, so they will be almost ready when you place your order in restaurants. Automation like these becomes even more fascinating when they give a touch of love and care. Here are two sorts of nuggets being made, and if you ask me, both are something delicious enough to die for. I'm kind of a huge foodie. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is important in maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. That's a step which is typically 2 in 1, meaning they keep on drying naturally while moving ahead towards further processing, which will be peeling. Obviously, what else could it be? Potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins so they can be moved to these big choppers, which literally cut the potatoes into uniform chunks. This factory is literally multitasking because it doesn't only prepare potatoes for silky smooth mashed potatoes, but also gets the various forms of potatoes ready for dozens of cuisines. For example, here the special cutters have cut the potatoes into wedge shapes, so potato wedges aren't a hassle. While some of the peeled potatoes are sent for further examination, a bunch of experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait more to show you guys the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, these experts are boiling the potatoes right on the spot. Meanwhile, in many households like mine, where spare time is literally an issue, already boiled potatoes, boiled a day or two before, are used to make mashed potatoes really quick. But these buddies know never to compromise their crowning taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their Disney oil treatment in a smooth blender. As they are the main character, the blender keeps on rotating, while, bit by bit, butter is added into it to give them a thorough and creamy blend. Talk about creamy. In order to make mashed potatoes creamy and dreamy, they'll pour in a specific amount of milk and mix it all over again. This gives the mashed potatoes a smooth texture, and that perfect consistency makes you crave having more. And there you have it. The superheroes have gone through the ultimate transformation, and the best one, ready to be served as a delicious, creamy side dish or main. It totally depends on your taste. Never underestimate any smaller element, even if it's a small gesture or machine like this nozzle, pouring the equal quantity of mashed potatoes in every batch. It was literally a team effort, but we don't end here. There's a lot more craziness to watch, so stick with us. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. So, starting off right with smooth and fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and neatly spread over the baked dough by some automatic machines, so they do not really need manual help. You know, cheese could go bad, so before it may ruin the entire pizza party, they check it for its top-notch quality beforehand. If it's good enough, the crushers shred the entire cheese blocks and sprinkle them over thousands of pizzas to give these pizzas a perfect texture. Some more cheese slices are neatly added onto them to finish it off. They pour some other sauces and ingredients, so the pizzas are ready to be frozen right away. Finally, the pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines won't even demand appreciation, but they do deserve it, right? So hit the like button for the sake of these and many such robotic machines working tirelessly to give you the perfect outcome every time. Just check out how this ordinary-looking dough is going to transform into the perfect buns with a single push of a button. Yes, this entire automation you're watching right now on your screens doesn't involve manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls are kept for a couple of minutes until the dough rises again, and the vacuum can blow off extra crumbs to give it a neat finishing look. However, when the buns are perfectly baked, they are all set to get dressed. Hey, if you like our video, please give it a thumbs up and support us for creating more of such content for you guys. As I always say, you're all we have. Look at those nozzles pouring out the delicious jam on each half to give the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with the blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. Rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. This is so beautiful. How these machines continuously knead the candy material without taking a break to make sure it perfectly fits your standards. Now, that little automated machine makes sure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps the bunch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The candies are then packaged into boxes using huge packaging machinery. This step prepares the candies for distribution and makes them ready for shipping. Stop messing with your sweet tooth nature. Not everything sweet is worth tasting. So grab only your favorite honey-topped biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy candies that are crispy from the outside, but a mouthful of liquid flavor bursts into your mouth as soon as you munch them. First, they mix these ingredients together in a big machine until it's just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which is not going to take so long. Once the candies cool down, they're taken out of the molds and spun around in a special machine. This makes sure they're the perfect size, shape, and texture. They make lots of candies this way, so there are tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They make sure everyone can enjoy their favorite flavored candy and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. They surely turn snacking into a fun journey where you can discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with different sweet and savory sauces later by bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all up into equal-sized pieces and packs them neatly into cans. They seal each tin tight with a cover and label using robotic hands in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for a magical machine, shaping it into equal-sized pieces is no big deal. As soon as the dough is ready and balls are prepared, they undergo a smooth waffle-making machine that rolls them up while baking them in the meantime. This ensures no additional time is wasted, and the result is just hilarious. In today's busy time, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when enjoyed in various ways. Transforming the amazing juice and fresh fruit flavors into sweet delights and candies is a breeze for robotic machines. Advanced machinery ensures these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic machines cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch this video, and you'll see how these machines make the perfect donut-shaped sponge cakes, which later will be topped and dipped into creamy and rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. After finishing, they move on to the next process. Here's how sushi goes from a simple idea to the delicious rolls you love. Let's explore the world of sushi, where rice meets seaweed and every roll tells a story. Let's start with the star of the show, rice. First, the workers scoop up high-quality sushi rice and put the stock through sieves to make sure only the best quality grains make it to your plates. Now it's time to get them soaked in water to get the perfectly cooked sushi rice. Here, the rice pots are getting ready, and check out that one-push automation making everything pretty simple. Large machines are going to cook the rice in big batches, so they need to make sure everything gets in place. While the rice is rinsed multiple times until the water runs clear, they add a little bit of vinegar and oil to cook the rice up to the mark. Letting them settle for a moment, the pots are put over the stoves. These machines use precise temperature controls and timings to ensure the rice is cooked perfectly every time. Pretty good if they can check the right moisture and consistency. The rice is steamed and cooked until it's soft and fluffy, just perfect for sushi rolls. Garnishing with a little bit of oil will help to move the rice smoothly. The rice is gently stirred to make sure every grain gets coated with seasoning so that the flavorful rice sticks together just right. The seasoned rice is then cooled to the perfect temperature for rolling. Let's watch the preparation of the rest of the ingredients to make thousands of perfect rolls of sushi. With everything ready, now comes the fun part: assembling the sushi rolls. The machines spread the seasoned rice onto the conveyor belt, while the workers place the meats and veggies on top of the rice as it moves on a conveyor belt. From fresh, crisp vegetables to seaweed and other picked ingredients to enhance the flavors. Everything is all lined up for this step. The precise placement of these ingredients is crucial for ensuring that every sushi roll has a balanced flavor and texture. Thanks to the labor that finally made it possible, allow me to show you these beautiful scenes. Finally, the rice and filling are rolled up to make the delicious sushi rolls. This would all be done with the help of these rolling machines, which will perfectly roll out the assembled sushi sheets. Just look at those enormous sushi rolls. Aren't they mouth-watering? This one was a billion times satisfactory adventure that I'm never going to forget. The workers now cover the sushi rolls with seaweed sheets and feed the sushi rolls into the machine that slices the big rolls into bite-sized pieces. The ready-to-eat rolls are now all set to get covered inside the special packaging, which seals them to keep them fresh. Now let's set off on a tasty journey of the production of your favorite snack, kimbap. Workers carefully add a mix of spicy sauces to the freshly cooked rice. This blend of flavors gives the kimbap its unique kick. The rice is stirred with precision to make sure every grain is coated with that zesty, spicy goodness. After the rice gets its spicy makeover, the machines spread it evenly, and it is then topped with meat or other preferences and sauces to add crunch and color to each kimbap pack. This is exactly how kimbap gets its crowning triangular shape. This shape makes them easy to grab and even easier to enjoy. Each piece is carefully cut to make sure it's just the right size for a perfect bite. The neatly cut kimbap pieces are placed into individual packs. Each pack is sealed tightly to keep the kimbap fresh and flavorful. And that's how your favorite kimbap packs come to your plates. Let's now move on to another beloved snack, crispy fried chicken nuggets. These nuggets are a favorite among people of all ages, and their production process is as fascinating as their taste. First, large quantities of fresh chicken meat are brought into the factory and prepared for processing. The chicken pieces are carefully cut into uniform shapes and sizes by high-speed chopping machines, ensuring each nugget is consistent. Once cut, the chicken pieces are passed through a marination station where they are coated in a blend of herbs, spices, and seasoning. The marination process ensures that every bite is packed with flavor. After marination, the nuggets are passed through a battering station where they are evenly coated in a smooth, flavorful batter. Following this, the nuggets move to the breadcrumb coating stage. This step ensures the nuggets get their signature crispy texture after frying. The coated nuggets are then partially fried. This partial frying process locks in the juiciness of the meat while giving the nuggets a golden brown color and a crispy outer layer. After partial frying, the nuggets are rapidly frozen to preserve their freshness and flavor. They are then packed into airtight bags and prepared for shipping to various restaurants and retail outlets worldwide. Next, let's talk about potatoes. Potatoes are one of the most versatile foods, and their journey from the farm to your plate is nothing short of extraordinary. After being washed, scrubbed, and peeled, the potatoes are sent through slicing machines that cut them into various shapes. Some are turned into classic fries, others into wedges, and some into thin slices for chips. These potato cuts are then rinsed again to remove any excess starch. They are then partially fried in large industrial fryers. This step ensures that when you cook them at home or they are fried at a restaurant, they will achieve that perfect, crispy texture. After frying, the potato pieces are rapidly frozen and packed into bags, ready to be delivered to your favorite fast food outlets or grocery stores. Now, let's dive into the world of frozen burger patties. Large cuts of fresh beef or chicken are brought into the processing plant, where they are ground into a fine texture. Seasoning is added, and the mixture is carefully blended to ensure even distribution of flavors. The mixture is then fed into patty-forming machines that shape the ground meat into perfectly round patties. These patties are then passed through a cooking tunnel, where they are partially cooked to lock in moisture and flavor. After cooking, the patties are rapidly frozen and packed into individual portions. This ensures they remain fresh and ready for cooking whenever you crave a burger. Next, let's explore the production of creamy mashed potatoes. Once the potatoes are washed, peeled, and boiled, they are transferred to large industrial blenders. Bit by bit, butter and milk are added while the blenders mix the potatoes into a creamy, smooth texture. The mixture is carefully monitored to ensure it reaches the perfect consistency. After blending, the mashed potatoes are portioned into containers using precision nozzles. Each batch is sealed to maintain freshness and is then prepared for distribution. These ready-to-eat mashed potatoes can be found in grocery stores or served at your favorite restaurants. Now let's move on to one of the most beloved treats, honey candies. The process begins with blending pure honey with other ingredients, such as sugar and natural flavorings. This mixture is heated until it reaches the perfect consistency. Once the candy mixture is ready, it is poured into molds to give it the desired shape. After cooling, the candies are removed from the molds and passed through quality control sensors. These sensors ensure that each candy meets the required standards in terms of size, shape, and texture. Once approved, the candies are wrapped in protective packaging to maintain their freshness and prevent them from sticking together. They are then packed into boxes and prepared for shipping. Let's not forget about donuts, a treat that brings joy to people worldwide. The donut production process begins with preparing soft, fluffy dough. The dough is mixed, kneaded, and portioned into uniform shapes using specialized machines. These dough pieces are then transferred to donut fryers, where they are fried until they achieve a golden brown color. After frying, the donuts are cooled and passed through a glazing station, where they are coated with a layer of sweet icing or syrup. Some donuts are also filled with cream, jelly, or chocolate using precision nozzles. Finally, they are packed into boxes, ready to be delivered to bakeries, cafes, or grocery stores. Now let's talk about sushi, an art form as much as it is a meal. The process begins with cooking high-quality sushi rice, which is seasoned with vinegar and sugar. The rice is cooled and then spread evenly on sheets of seaweed by automated machines. Fresh ingredients like fish, vegetables, and sauces are carefully placed on the rice. The sheets are rolled into cylindrical shapes using specialized rolling machines. These rolls are then cut into bite-sized pieces using sharp, automated knives. Each sushi roll is inspected for quality and consistency before being packed into airtight containers. This ensures the sushi remains fresh and flavorful when it reaches your plate. Kimbap, a popular Korean dish, follows a similar process. Freshly cooked rice is seasoned with a mix of sauces and spices. The seasoned rice is spread onto sheets of seaweed and topped with a variety of ingredients, including vegetables, meat, and sauces. The sheets are then rolled and cut into triangular shapes. Is carefully wrapped in protective packaging and sealed to maintain its freshness. These neatly packed kimbap rolls are then shipped to grocery stores, convenience stores, and restaurants worldwide. In conclusion, Whether it's fried chicken, cheese cubes, nuggets, potatoes, mashed potatoes, burgers, donuts, sushi, or kimbap, every product goes through a series of meticulously automated processes. Each step is carefully monitored and executed with precision to ensure quality, consistency, and safety. These automated machines and advanced technologies play a crucial role in delivering your favorite snacks and meals to your plate. From the farm to the factory, and finally to your dining table, every step is a testament to human innovation and the tireless efficiency of modern machinery. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical, as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because over-drying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. Artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, 3 factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, The production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world.